All right, welcome back, everyone. So far, we've gone to the point where we were able to build a neural network that was able to take in multiple inputs and return a multi-classification answer, right? And just to bring up TL draw so that we could visualize it one more time. All right, here's the neural network that we currently built. We discussed how its output is determined in percentages, and it is the sum of one, right, or 100%. And we're getting probabilities as to which one of these five separate labels that we're passing in, or in this drawing here, we have four labels. We're getting probabilities as to which label it's likely to be. In this case, it looks like 55% was set for label 3. So that's what our answer would be, right? Well, it's great that we were able to build all of these neural networks, that we really went in depth into deep learning. We understand how to build the training process, and we applied a little bit of optimization to our model. Rather, there's still a long way to go. There's a lot of other concepts out there that you could really go into. For example, there's such a thing as AtomW, and you could learn about step schedulers when it comes to your learning rate. You could also learn about other activation layers and a couple of different techniques when it comes to building your linear layers or your hidden layers. For example, a really good one to look into is called bottlenecking, if anybody would like to take a look at that. But now that we have our model and it's able to work, well, how does this work in real life application, right? Well, we're going to concentrate in the backend server of this information. And honestly, we could probably make an HTML template with a script that will be able to do this as well. But I'm going to leave that part as a stretch goal, since currently it's already 9:04, and we may run out of time. Right? So instead, I'm going to sketch out what our front end would look like here on TL Draw. Well, if I were to make a front end template for this site, my front end template would say something like, hey, student registration for class, right? And for this class, I would have those attributes that were provided to us by our data set, right? So if I were to go to find some multi-classification data sets, here we see our student performance, and we could see all the attributes there being listed. For simplicity's sake, I'm going to grab it out of my database here. I believe I have oh, here you go. Here's the CSV example. I would paste it, and I would have something that works in such a manner where I would ask for all of these fields to be provided on the front end site, right? And this shouldn't be too extreme. I think for almost every time I signed up for a school, they've asked, hey, about my parents' education and all these other factors. So hopefully it's not too intrusive, right? And then there's like tutoring, if any. And I could make it to where the user could provide null values if I really wanted to. But due to the way I manipulated my data, maybe I don't give them an option to do so. I can tell them, hey, at most you could put 0. Right, and I'll have some sort of JavaScript in the background running, trying to get an average or turning all of these fields into the same data that we had here. So for example, the study time weekly, well, currently right now we have like 19, 15, and we don't exactly know what the interpretation for that would be. So instead, I would just ask the person registering, hey, provide me, are you studying? And if you are, how many hours a week do you think you're studying? Right, and this would all be input fields. Oh. Excuse my crookedness. All right, so that way a user can actually log into the site. They would come over to this page. They click on each one of those fields to be able to register for a class. And then this could either be a form or it could be a form or it could be a ridiculous amount of fields, but they would have to have an click function rather than just being able to press enter, right? Well, now a student registers for a class and then they get left into a pending status, right? And after they get left into a pending status, well, then they're being told, you're waiting for approval. If you're approved, you'll be put into the class. Well, on this teacher side, what they would see, and here's the teacher portal for class. What they would see on the left-hand side would be a list of names, right? And let's say in this case specifically, the list of names has, I'm not going to do anything too crazy, but it has myself. Let's say it has Adam. It has Nick. And let's say it has Zainab. All right. Well, it would provide those values for us being able to register, but this teacher may also have a field to the right-hand side where it says expected grade. Right? The algorithm is making a prediction, trying to figure out, well, what kind of grade would this individual receive in this class? And maybe my expected grade is an F. Maybe for Adam, they expect Adam to get a B. For Nick, they expect Adam to get a C. And then finally, Zainab getting an A in the class. Well, where did this expected grade come from? That's where our algorithm or our neural network would take in all the inputs from the student being able to register and make a prediction as to how that student would perform in the class, right? And then I myself as a teacher could decide if I do want to take that into consideration or not, and who I would accept into the classroom, right? So that's our scenario here of the dots that we're trying to connect or the practical use behind the model that we've made. Does anyone have any questions over that so far before we start getting into some code? All right, so let's start getting into some code. Now we have all of this information and it's all been set up in a different format. So I'm going to go and break down our application here a little bit. Currently in app.py, you'll see that I'm starting a Flask server, and actually let me fix a couple of things here in my environments. I have to enter an interpreter path. All right, so that identifies it, and I also need to activate said Python virtual environment here. All right, so now I have my Python virtual environment activated within my terminal, and it's also the correct Python interpreter inside of VS Code. But you can see here that I've imported Flask. I have a couple of other things here from nn.module, which we'll discuss here shortly. And then I have a database module as well, or nn underscore model that we'll discuss here shortly. And then we have this database as well that we'll discuss. All right, so I start my Flask app. I add the configuration for PsychoPG to be able to determine that this is the correct path to my database that I am working with. If I open up SQL and I enter lmdb, you'll see that I have that there, and I have a couple of relationships, which we'll be discussing here shortly as well. We'll actually drop all of this information here. And then we have our app configuration, right? And this app configuration has to do with trying to create or attempting to create this database through Flask rather than creating it through SQL. We won't put it into practice, but it's a good thing to start looking into as well. What is this DB argument, right? Where is that coming from? Well, it's coming from the database. It's coming from the script named models. So here I'm utilizing Flask SQL Alchemy to make an instance of SQL Alchemy with DB to be able to make this prediction data table, which if I were to turn into true SQL, looks exactly like this, right? So there's our prediction being created, my ID with server primary key. I have my input data. Doing text for simplicity's sake. Preferably, we would want a pickle type here, but text will do for now. And then we have prediction. Right. And then finally, I took some of the student samples that we had inside of the data, and I turned it into a JSON file. The reason why I did this is so that when we start making requests to our server, we could simply just copy and paste these JSON bodies and turn that into the body of our request. All right. So that covers database. The DB instance gets initialized. Oh, wow. The DB instance gets initialized within the app. And then at that point, we go into lm.model. lm.model stands for NN model. Here we have our learning model itself, right? We've been doing everything inside of Jupyter Notebooks, but it's still just a Python script. So now I've brought the same exact model that we worked in yesterday. I placed it here inside the script named learning model. I have my early stop class as well. Excuse me. And then I have my pre-processing script for being able to grab data, turning our data into readable information, and having my training and test loaders at the end of said script. Finally, all of this gets used inside of my regulating and evaluating class, or excuse me, script, where I bring in I bring in the early stopping, I bring in my learning model, my training loader, and my test loader. I create an instance of early stopping, create my optimizer and my criterion, and then I have a function named train the model, which iterates through 200 epochs to be able to train the model and has an early stop function being implemented. And then I have an eval model function, which goes through the entire testing loader and evaluates the accuracy of my model. At this point, does anyone have any questions of the structure of my project? Okay, if no one has any questions over the structure of the project, let's go ahead and take a look at app. Oh, go ahead, Momo.
Yeah, the evaluation model. Why did you make a function here?
Yeah, why
When
did
we
I make it a
create
function?
our yes.
Awesome. So I created this into a function because once I run my app or I run the server, if I don't create this into a function, it's going to be triggered every single time, right? And it's actually going to go through the iteration of trying to train my model and trying to evaluate. I don't necessarily want this to happen on deployment. Let's say I deploy the server and it gets put into some sort of cloud server. I wouldn't post my model with the necessity of needing to be trained still. Like my model would already would be trained, and I would push it onto this cloud with its weights and biases already applied or ready to be applied, right? The only reason why I would still have this logic on that cloud server would be more of like an emergency thing, or of, hey, model is doing some misbehavior, what's going on? We need to figure out if it's acting differently on the cloud than it is inside of whatever machine we're utilizing to train it. Then we would have this endpoint, or the whatever endpoint would trigger this function really hidden and not exposed to anybody except for people internal to the organization. And then we would send a request to this endpoint to trigger this function and find out how our model is performing in the training process. And same thing with evaluation, right? I don't want this to run right away. I want to have it upon request. So essentially, to summarize my response, it's because I don't want this to be executed as soon as I run the server. I want it to happen upon request.
Oh, okay. Yeah, so that's why you make it function for both, for the training
Correct.
model and for the accuracy. Yeah. Thank you very much.
Of course. All right. So going back to our app, this should look pretty familiar, but just to do a refresher, we're utilizing a decorator here from Flask, where we're calling the app itself and applying a route to set app. This decorator should be applied to a function. We've talked about HTTP methods, which would have get, put, post, and delete. Get for getting information, post for creating information within the database, put is for updating information within the database, and then delete for deleting information within the DB, right? Well, in this case, it's just index, and I wanted to return hello X-ray. Well, let's see what our Python script does a certain. If I run Python app.py, we can see that my Flash server is building. It's building on port 8000 because that's the port I provided for it. All right, so it's working. Let's bring up Thunder Client here so that we could have a couple of requests being applied. All right. Well, I send my request to HTTP 127.0.0.1, which is my local host at port 8000 slash. My slash triggers this index function, and the index function returns hello X-ray. And that's what we see here. A status code of 200, the request was completed correctly. And the body of my response was hello X-ray. All right. At this point, does anyone have any questions regarding how this model, or excuse me, how this application is working when you're building a Flask server? All right, it doesn't look like we have any questions. So let's go ahead and apply our very first endpoint here. All right, currently the way I have it set up, we still have to train the model because currently we don't have any weights and biases being saved. So I'm going to go ahead and add a function here, which is going to say train the model. And this function will return a JSON response of the train model function. All right, so I'm going to call this endpoint, or this endpoint will trigger this function. And this function is just going to return the response of training the model. So training the model will iterate through the number of epochs with an early stop, and it will either return early stop at epoch with the validation loss, or it will return here's the loss at the final epoch. Right, so those are the two types of responses that I could expect here. One of them applied from early stop, the other coming from the completion of my training iteration. But I want to create this into a route. Okay. So how could I turn this into a route? Because currently right now it's a function. How do I turn it into a route for Flask? Let's hear it, Momo.
I remember you the decoration function at yeah something get and then the route.
Awesome. Yeah. So we would still utilize the
Yeah,
decorator. You want to call
yeah.
the route, and we
Yes.
want this to fall for train. And again, my method here is just going to be a get request. All right, so we can see that my server crashed because it thought there was a syntax error, so it stopped working. I'm gonna run my server one more time. And now I'm gonna send my request again. Right. So I send my request to index, still gives me hello X-ray. And now let's send our request over to the training endpoints. All right, so we can see it's iterating through my epochs. We can see all those print statements happening on my terminal. Okay, it looks like my early stop function was triggered. So early stop was triggered at epoch 108, and my validation loss was of 1.13. All right. Great. I could send it again to this endpoint, and I know that I'll at least get a couple. It looks like I didn't, and that's because of my early stop function. All right. Great. So there's my train. All right. Now that I've gone over my training, well, let's go into the evaluation of my model. All right. So following this format, how would I make a route that would return the result of my model's accuracy? Let's pass it on to someone else, Momo. I don't want you to be the only one participating. All right, let's go ahead and pass it on to Robert. Robert, following the format that we've seen above in the last two endpoints, how would I create an endpoint that would return the response of the evaluation model? Or excuse me, the evaluation function.
Let's. I mean, it looks at app. I mean, it looks like that's what we're copying, right? At app.root.
Mhm.
And then parentheses or quote backslash, and then was it eval? And then method equals get with one or two parentheses. And then def, did we make an eval the model?
Yeah, eval the model.
Colon, and then return JSONify. Looks like eval.model.
Yeah. So there you go. We have all of our information, right? Now notice that my application crashed again. So every time my application crashes, the way I have my application set up right now, technically whatever weights and biases that my model had just got thrown away. All right, so we'll talk about the way of saving these weights and biases here shortly. I'm gonna run my app again. You can see it compiling. I'm gonna run over to my request. Attempted my request to index, that worked. Send my request to train, which seems to be broken. Oh, excuse me, it's not broken. And there we can see it iterating through the number of epochs. It's making it a lot further this time. Okay, great. It made it through all 200 epochs this time. And we can see that my loss came back at 1.08. All right. And now we can ask for my evaluation of my models. So I'm going to send my request to evaluation. And we can see that my model's accuracy is now at 0.84. Great. All right. So my model, I can get my accuracy through an API endpoint so that I, as a developer, can see how accurate the model is working. I can also train the model through an API endpoint so that I can see how the training process builds my model. But just like I talked about before, it's not uncommon for a server to turn off, or for us to temporarily turn off a server when we're trying to add a feature, right? So if that's the case, or we're trying to figure out how we want to implement something new, well, I need to be able to save all of the weights and biases from my model. Specifically in this example, right? We saw in the first one, the first training iteration, that my early loss function was applied at my step 107. Where in my second training iteration, I was able to apply all 200 epochs, and my early loss was never triggered, right? Not only that, but my loss was significantly small. It came all the way down to 1.08. So I don't want to lose these kind of results from weights and biases. So there's got to be a way for me to save my model. And we haven't talked about that just yet, right? Well, PyTorch comes with something built in, or excuse me, I shouldn't say something, comes with a function built in that will allow us to save our information of our learning model. Excuse me. And it does that by creating a file where it's essentially storing all of the information that belongs to the parameters of our model. So we're going to add that line of code here. Right? After my training model is, or after my training process is completed, so before the return of my response, I want to save all the weights and biases of my model. Well, I'm going to do that utilizing the function from PyTorch, which is called torch.save. This torch.save takes in two parameters. One, the model that I want to save, and then we call this state dict. Well, the state dict, it essentially builds a dictionary of all of the different parameters. The current state of my model is being turned into a dictionary that whenever I open up my model again, I can utilize this dictionary to reload my model, all right, or put back all of its parameters that I have. And then I need a place to store it. Well, the place I want to store it, and I'm actually going to bring in, oh, I do have OS in here. Great. The place that I want to store this model, it's going to be on the absolute path. So my root directory of my project. I'm going to say os.path.appspath. And I want to call this model path. All right. Now this naming convention is pretty standard for OS paths or for learning models to make a text file. You'll see what it turns into here shortly. But essentially, this is the correct, the common standard as to what you should be naming this file. Don't try to name it something like, hey, this is my model parameters or something like that, because people who work in machine learning are expecting to see this kind of file in store so that they can load the model's learning process, right? Well, just like we're saving the model, and let's actually try to run this function by running the train endpoint. I'm gonna run get. Looks like it's still iterating through a couple of epochs there. All right, so now I have a 1.1, and we can see this model PTH has been created. Right? So now this model PTH, if I click on it, it's gonna tell me, hey, we don't have anything that can interpret this in VS Code. Is there anything you would like me to do? I'm gonna go ahead and click on open anyway. Click on text editor. And we could see that this is all compiled code, right? These are our zeros and ones. And we can't really read it, but essentially all it is a massive dictionary that has key value pairs for each individual layer, matching the weight, or each individual layer's biases being matched and described throughout this dictionary. All right. Well, now that I have a way to save my model during training, how would I want to load this information? Well, we would do the same thing, but backwards, all right? I would, let's say before I go into my evaluation for my model, so I want to grab my LM model and I want to load the state dictionary. I can say, hey, I want you to do this from torch.load and then os.path.abspath and pass in model path. So this way, I'm going to go ahead and run the eval process. If I send my evaluation, it evaluates to 83, right? I'm going to comment this out real quick. So currently it evaluates to 83%. If I send this request again, I should still get back somewhere around, oh no, it doesn't. So now if I send this, it's not actually trained, and we can see that my accuracy is significantly lower than what it was before, right? Whereas if I bring back this endpoint or this line of code, well, now it knows how to load its state, and we can get back that 83%. Right? We're essentially saving all of our weights and biases of our model into a separate file. This file is then going to be referenced to load all of those weights and biases back into the model after the training process has been completed. All right. Does anyone have any questions about this so far? Let's hear it, Mama.
Okay, when how the model or how the training model update the update itself, or update, I mean, if you someone add new input, okay, the user, and there is a new data get in now, okay, if the model will use this new data for the training model like automatically?
Yeah, that's a great question. So you're saying, hey, a user or multiple users are sending requesting, right? And now we have their data. How do we update our model? Well, that wouldn't
Yes.
happen. Yeah, that wouldn't happen here, right? That would be a completely separate process as far as updating our model. And we would essentially do the same thing, right? We would take our predictions that we made for the current people registering for the class. We would wait for them to go through the entire class and take their outcomes, right? And we would probably want a large sample size. So maybe it could be like a couple of years that it would take to be able to get a good amount of data. And then after that, we could go and try to retrain our model, right? But you have to make sure that you have a good data to be able to do so. Does that make sense, Mo?
Yeah, so it's different process.
Right.
Okay, thank you.
Of course. All right. So now we have a way for saving and loading our state back into our learning model, right? And it works great within my JSON response. But now, what if a user wants to send their information to us, right? Just like we mentioned before in the example, a user could possibly want to, hey, I want to send all of this information. Well, now we get back this row of data, right? Let's say we get back this row of data in the response body. I'm gonna go ahead and stop my server here, right? Let's say we build a route or a function here that says make prediction. And we know that we're supposed to receive a request data. So we go into request.data and grab the body of our request. And the body of our request looks like this, where we have a dictionary that has, oh man, let me go ahead and just grab this straight from here. Right, we have a dictionary that comes with key pair values representing our student. Right, so this is what we get in the body of our request. What issues could we run into if I feed this straight into the model, or what's the problem with this data that I have right now? What's your Mo?
Yeah, it has like text.
Okay, yeah, I have my text on the left side, right? But I could fix that by grabbing all of the values. Now, let's take a look at our drawing here of what we've done before, right? What we're receiving through that request is a pure data sample. But we have to standardize and scale our data before we feed it into our model, right? Not only do we have to standardize and scale the data, but we can't randomly standardize and scale the data all over again because we need to have consistency, right? So just like I stored my method or excuse me, my parameters for my learning model, I need to find a way to store all of the parameters for my standard scalar, right? Because that's what I utilize to standardize and scale my data. I need to do the same thing within the request of my application. So let's get into how I would store this information here. In my pre-processing class, right, or in my pre-processing script, I have my standard scalar. The instance was already created and it already looked at some features to be able to transform them. Well, once it transformed them, it saved a lot of the information as to what it did to be able to transform those features within the instance of the class. You would think, oh, well, why can't I just call the class itself from app.py, right? Like I'm doing here. Well, you can, but that's only going to work while the server is running, right? And as we saw before, if my server crashes or I kill my server or someone's trying to make a new push, we wouldn't have the same consistency within Scalar because it would be a brand new instance of said class. Well, just like we stored all of my model parameters, I want to store all of the parameters that fall within Scalar. So I'm going to go back to my pre-processing here. And inside of my pre-processing, at the very end, I want to say with open, I want to open a file called scalar.pickle. And then I'm going to pass in WB, all right, which is essentially going to write or create this file. So if this file doesn't exist, it's going to create said file and then write on it. And then I want a way to dump all of the data that is within standard scalar. Well, the weights and biases or the tensors that are being saved In Python, they're typically referenced to as pickles. So I can grab something called pickle, which is a specific data type, all right? And now, utilizing this function of with open, I can say I want to pickle dot dump, meaning I want to dump all of those weights and biases or parameters that are within Scala. And I want to dump them into the file of f, which is the scalar.pickle file. All right. Now this is going to save all of my Scalar parameters. So that means that within app.py, I can load them back again. And let me make sure that I'm grabbing the correct piece of code here. All right, within app.py, after my model is back into evaluation mode, right? I want to say, well, with open, I want you to grab scalar.pickle. I want you to read this information. And I want to reference this as f. And then I'm just going to simply set scalar equal to pickle dot load and the file. And of course, I have to import pickle. All right, so now I saved my method for Scalar, which is going to allow me to scale my information, right? Or standardize and scale my data that's coming in within my request. All right, so I'm taking a step further here. So currently I have a way to put my model into evaluation mode. And actually, before I put my model into evaluation mode, I want to ensure that my model is loading the state dictionary of torch.load. And again, I want to utilize os.path.abstract for model path. Right? And let me go ahead and import both of these. So I want to import torch. And I want to import OS. All right. So there you go. I have a way of loading my model, placing it back into evaluation mode, and I have a way of loading my Scalar information to be able to scale and standardize my data. I covered quite a bit of information. I want to go ahead and open up for questions. Does anyone have any questions over how we saved and loaded both the parameters of my learning model and the parameters of StandardScaler to be able to scale and standardize data? Go ahead, Mama.
Yeah, why we scale this data again? This data already scaled before, right?
Yeah, the data that was scaled before was the data that I utilized to train my model, right?
Yeah.
But the data that I'm talking about down here will be data that a user inputs through the site, right? So my user will fill out the form that I created, send that request, and when I receive that request, it's going to be not standard and not scaled. So I need to scale it and
That's the new.
standardize it.
Oh, that's the new data. Okay.
Exactly.
So, but okay, do we need also to make the normalization for this data here
That's what we're
before the
doing.
scaling step?
That's why we're grabbing the standard and scale. We're normalizing the data doing that with Scalar, right? So here's what we're doing. We're utilizing a fit transform. We would do the same thing within app.py.
No, I mean the the step of cleaning the data, like if we have duplicate data or if we have empty cell.
No, right, you would handle the empty cell. You could handle the empty cell in the backend if you would like. What I would do is just give users, I wouldn't give users the capability to provide you no values if your model depends on it to be able to read it, right?
Uh-huh.
And then
And the
you don't need,
duplicate?
you don't need to worry about duplicates because you're only getting one row at a time,
Okay. Thank you.
of course. All right. So we have our data, we want to work with said data, and we want to return our target. Well, let's go back to Kaggle here. Let's take a look at our targets, right? So at the very bottom of this file, it tells me, hey, 0 matches 1, or excuse me, 0 matches an A, 1 matches a B, 2, etc., etc. Right? So I'm just going to simply create a dictionary that depicts this. So I want to say, hey, my grades, or I could call these labels, whichever one you would like to utilize. But here's 0 with A. We have 1 with B. 2 with C. 3, which is D. And then finally 4, which is an F, right? So there's my request data coming in. So I have my request data, and request.data is typically just a binary string. Let's take a look at this. I'm gonna make this into a route, and this route's gonna be named predict. I'm gonna pass in my methods. And in this case, the method that I will accept, because I am going to create a prediction within my database, will be post. And actually, let me go ahead and run this SQL script here. Right, I have to exit, and I have to, there we go, ls, SQL. All right, so I just dropped the table and created it so that it's empty, right? So now if I run select all from prediction, you'll see that it's 0, and it's taking in input data and predictions, right? So that's where I'll be storing my predictions once my model makes them. All right. So here's my data. I'm asking for a request. Let me go ahead and return. For now, let's just do JSONify A. And what I want to do is I want to print data so that everyone can see what data would be interpreted as. All right, let me run my server here. I'm gonna grab this sample. Come back over to Thunder Client. Oh, that's the wrong one, but let's do predict. I want to send a post method this time, not a get method. And in the body of my request, I want to include this information, right? All of my students' data. So my student inputs all of their information inside of the input fields. And I have a script in JavaScript that will churn said information and format it to be inside of this object. Finally, this object gets sent over an HTTP request of the method of post, and it's processed by my app. So let's go ahead and click send. All right, it goes through, and we can see that I got the response of A. And if we take a look at our response here, well, it's coming through, but it looks pretty weird. What data type is this, right? Does anyone notice something weird? Because it's supposed to be an object or a dictionary in Python, but it seems like it's coming back as a different type. Let's hear it, Brandon.
Is it a string? I see the quotes.
Yeah, so the very parental part is a string, and then there's a B at the end of that. Well, that stands for binary string, right? Well, it's coming through as binary string, so I need to load it so that I can actually work with it in Python. So I'm going to say data is equal to request, oh, excuse me. I wonder what happens if I do this. All right, I'm going to go ahead and add that .json there. Run my application, which for some reason is taking a ridiculous amount of time. All right, I send it. Now it goes through. I still get back A, but look at the difference, right? Or the body of our request is now an actual Python dictionary. It comes in as a binary string, but by utilizing the .json attribute, I am turning it into into an actual Python data structure that Python can work with it. All right. So there you go. I have my information from JSON. I can now work with my data coming in from my request. What's the next issue that I could run into? Feeding it into my model. All right. So when it comes to dictionaries, there's some benefits and there are some weaknesses. Right? One of the major weaknesses about dictionaries is that you can't expect them to always be ordered. Right? They do grant you direct access, but you can't expect them to work in an organized fashion. Meaning that if I try to write a for loop through this, I shouldn't always expect there to be the same order. So I need to ensure that this is the order that I grab my features in. I'm going to do that by building a feature order. And this is going to be a list, which includes my student ID. It has my age. Then there's gender. I'm not going to torture everybody and make you all watch me type this out. Instead, I'm going to grab this from my example that I have and bring it all back here. All right, so there's my feature order. You can see it iterate down the list. We have the correct orders that my features are supposed to be interpreted as, so that I can actually grab these features in an organized fashion. All right. So now I'm gonna call my ordered features, which is simply going to take the dictionary that's coming from data. I'm going to utilize the get method of X for X in feature order. All right. This line of code is going to iterate through each index inside of my list. And for each index inside of my list, it's going to build a brand new list that will have the correct value for the responding key. That's how I ensure that my features will be placed in order. All right, covered quite a bit of ground so far. Let's do a little bit of a review. We're going to send our request. We're going to then JSONify our request to make sure that we can work with it inside of Python code and it's not interpreted as binary string. We build this grades attribute, which is going to help me send back a response. It's going to match my prediction to the correct label of A, B, C, or D. And then I realized that a data is a dictionary that's not always going to have the correct order. So I have a feature order list. I then iterate through this order to be able to create my ordered features. All right. At this point, does anyone have any questions over what we've done to build out this function so far? Send it, Momo.
Yeah, just the part of I got everything, but when you reference to the input to get the data to the body in this step, can you back to the body?
To the body.
When you-
Are you referencing this?
Yeah. No, the body. Yeah. You know, when you said, okay, now the data that the user input, okay, we will post it in the body.
Mm-hmm. Yes. Are you saying this here?
Yeah, exactly. Yeah. I
Okay.
didn't understand this step.
Got it.
How,
So-
how this connection happened. Yeah.
Yeah, so we've seen it so far. We've utilized Axios to make requests.
Yeah.
The way this would be written in Axios would be something like, oh, that's weird. It would look something like const response is equal to await, and then this would then send a Axios dot post. All right, it would go to HTTP : 127.0.0.1 at port 8000 / predict. All right, and typically right now, what we've seen is just the get method. So now when I'm making a post and I'm sending a body of a request, I would specify data is equal to, and then here I would have a object with key value pairs. I would then close that object and close the request. So this is what it would look like if I was working within JavaScript to be able to send that request, but I'm just using Thunder Client. It's doing the same exact thing. I'm just using a different tool. Does that answer your question, Mama?
Yeah, that's answer the question. Yeah, thank you.
Of course.
So I'm not gonna, I don't, I will not need to do that. I can use standard line.
You could use Thunder Client, yes,
Okay, thank you.
of course. All right. Any other questions? All right. Doesn't seem like there are any other questions. So let's go ahead and continue moving forward with this featured data. Well, now that I made my data and that I have it in, the correct order, I can start with the manipulation of said data. But I want to take us a step back here, and I want us to think about our pre-processing data. Here, when I ran scaled features, scalar fit transform on features, this is my features here. What type was this? Or what kind of data type were we interacting with at this point? It's here, Momo?
Binary?
No. Not binary. It's definitely not something as simple as saying we were interacting with a list or a dictionary, because what we were interacting with here wasn't pure to Python, right? Brandon?
Is it float 32?
So float 32 were the types that were within this data type, but it wasn't the parent. Robert?
Tensor.
Almost. It wasn't casted into a tensor yet. We did cast it into a tensor later on, though. Joseph?
NumPy array.
A NumPy array? Yeah, so it still wasn't a NumPy array yet, because as we see down here, we do end up casting things into NumPy as well. So when we run this pd.readCSV, what does pd.readCSV return? Eric?
Wild guess. Is it a data frame?
Perfect. Yeah. Where we're looking at here is actually a data frame. Right? Well, if I did my scalar to a data frame, well, it's only reasonable to think that we want to feed scalar a data frame yet again. So how do I build said data frame? First, I'm going to make sure that I import pandas as PD. Come down to my actual function. And now I can say, well, this is my data frame for my features. And my data frame for my features is built utilizing pandas.dataframe, where it expects the values to be provided first. In this case, the values are ordered features. And my columns are specified by the feature order. So I can specify, hey, this is the feature order. All right. There you go. So now I'm able to create a data frame. Well, now we could just follow down the pre-processing here, where the next step would be to transform my features. All right, I already have Scalar. Scalar's here, right up above. So Scalar's built out correctly. I have it available, but now I want to scale my features. So scaled features. And this is, again, going to take in Scalar. And instead of utilizing fit transform, because in this case, we're only interacting with one row, and we're not doing this from scratch, we wanted to repeat the same pattern that it utilized in fit transform on line 14 with my master data file. I'm only going to utilize transform. And with transform, I will pass in my data frame features to finally have a good scaled data. Well, great. I have scaled data. I see a question from Momo. Go ahead.
Yeah, sorry, one more time. Why didn't fit the data first before we transform it?
Why didn't I what?
Fit.
One more time. I think
When we
you're...
why we didn't fit the data? We used to fit, then transform the data, right?
Got it. Okay, so fit transform. We're working with only one individual row. And also when you utilize fit transform, if you utilize transform after this function has been called, a lot of the parameters that were utilized by fit transform are being applied again. Where if you utilize fit transform all over again, it's going to overwrite the original parameters for transform. So in this case, we're using it as a follow-on action named transform. Does that make sense, Mo?
I don't understand, but it's okay. Yeah.
Okay.
Thank you.
All right. So we have our scaled features. Everything's working within pre-processing. What's the next step, right? Well, before I was turning it into training and split batches, but that's not what I'm doing now. But, what is it that I feed my model? Because currently I have a NumPy array. Excuse me. I have a NumPy array. What's the last step that I need to do in order to have a tensor that I can feed my model? Go ahead, Mama.
Usually next step, we split the data, right?
Right, but in this case, we're not doing that because we're not splitting, right? We're just this is just features that we're gonna feed our model. So what comes after that?
after splitting, just setting the data and loading the data.
All right, so we
Create,
split the
create the
data.
loader.
So
Yeah.
if we split the data here, it looks like the loading function is way down there.
Yeah, data
Oh.
loader.
What about this? Right? I want to churn my information into tensors. So now I can finally call my features and assign this to torch.tensor that takes in my scaled features and has the data type of torch.float32. And now we have features that we can finally feed our model. If you're working with something like images, it's actually a lot easier. Torch has a specific extension for that called Torch Vision that will allow you to transform images and scale them in a much more friendlier manner. But for our model, this is what we have to do. So now that we finally have our features, we can go ahead and make a prediction. So with Torch no grad, because this shouldn't affect my model, I want my outputs to be equal to LM model. That's going to take in my features. From there, I want predicted, which is going to utilize torch.max, the outputs data, and it's going to match it to a solid integer. All right, and now I can return my prediction. Right, so here in my return statement, I am simply just going to return a object that says expected grade, and then grab my grades dot get and pass in predicted dot item. Right, because we so that predicted dot item returns the actual number within the prediction. Well, let's try to run this here. Gonna attempt to run my application. It seems like there are no errors within my application. It's able to compile correctly. We'll see if the API endpoint also reflects this. I'm gonna go ahead and open up Thunder Client, which I seem to have closed for some reason. Oh. And here in Thunder Client, it's weird. Here in Thunder Client, you can see that I already have my student ID. I have all of my student information, and this is student ID of 1001. So let's go into the sample here. Let's find 1001. Looks like it's the very first one. So here's the data for 1001. And the student is supposed to be a 2.0. So if we look at Kaggle, 2 is supposed to match for C. So when I send this request, I should see a C populate within my prediction. All right, so moment of truth. Keep in mind, our model is only 80-something%, so it could also provide us a wrong answer. All right, there you go. We get, hey, according to the student's attributes, the expected grade that the student is going to receive is a C. All right. So let's look at the overview of what we've done so far. So the behavior would happen, a student signs up for the class, everything gets placed into the not the neural network, into this form. From there, JavaScript sends all of these inputs to our server utilizing Axios or Fetch, whichever one you prefer. Our server grabs said information, turns it into JSON, turns it into Python code that we can work with. We then go through the process of organizing this data so that it's working in the correct order for features. We create a data frame for these features. We scale this data. And then we cast this data to be a PyTorch tensor of float 32. Finally, we feed this tensor into our learning model. Our learning model goes through the entire process of making a prediction, outputs its prediction, and then from there, we grab the corresponding prediction for that label. So what our output for our model was 2. It came up here, said grades 2, and grabbed the letter C. I'm actually going to move this line of code down below so that it's right next to it. Right, so grades.get 2 grabs the letter C, and that's what we get in our response of expected grade C. All right. At this point, does anyone have any questions over what we've covered so far? And I see Momo, do you have a question?
So we didn't split the data or load it because we take the data individually, like one data, so it go direct to the model, the training model.
Right, well, we're getting fed here. I'm not sure, let me see, how do I explain this? So if I go back to my drawing here on line 11, this pure data sample that we end up splitting, right? Or if you want to utilize the plain data sample, we end up splitting it, but this clean data sample has a ridiculous amount of rows and columns. Right? It's not just one entry. It has a ridiculous amount of rows and columns. I'm just gonna quickly do this. All right. And that's why we could split it and then grab data loaders that are of size 32 and all of that information whenever we're actually trying to break it up and feed it into our neural network. Well, at this point, we're not training our neural network. At this point, we're just expecting our neural network to provide an output, right? And what our neural network needs to be able to provide an output is a total of, in this drawing, 1, 2, 3, 4, 5, 6, 6 neurons, or 6 indexes inside of the tensor, right? So when this request comes in, rather than sending an entire file like what we've been working with, it only sends back the equivalent of 1 row without a label, right? All we're getting is features. And that's it. We're not getting anything else. Whereas before, we had a ridiculous amount of features and a ridiculous amount of labels. But this was utilized for training and evaluation, where at this point, we're past that. We're past training and evaluation. Now we're just utilizing the model. So all the model needs to work is features.
Okay. So it just giving us the last update of the weights, right, of the features. So we're gonna use this with the new data.
Right. It's only we're only getting features from the front end application or the client. The client is only sending their features through a response. Everything else, as far as weights and biases, different parameters that we might apply, dropout layers, how
From the old database.
Right. That's all done and over with. We're past that at this point.
Okay. Yeah, I got it now. Thank you.
All right. Any other questions? Go ahead, Mo.
That's mean when we build new application, like for example, creating like a new platform, social media platform. That means in the beginning, it will be very difficult to do this prediction, right? Because we don't have enough data before.
Yeah, that's a good question. It kind of depends on what your model is trying to do. Most of the time, if you're trying to build a model, somebody has likely. So if I think about social media, the main models that I would think social media utilizes is like sentiment kind, where it's trying to analyze what kind of statement it is that you're trying to make. If it's aggressive, if it's sad, if you feel anxiety, it's somewhere along those lines, right? And then that's fed into their entire network as far as deciding what kind of information they will show you and try to keep you on the screen as long as possible, right? So with that said, that has been done already. So you can likely find someone's model, or you can grab this from a public source as to what weights and biases they utilized to
Okay.
be able to create that model. And then you could just apply that to yours. Does that make
Yeah,
sense?
that solved the problem. Yeah, that solved the problem. Yeah,
Awesome.
thank you.
Of course. All right. So now that we're able to make correct predictions, and maybe we shouldn't just say that we're able to make correct predictions, let's pass this other student into the neural network and see what it gives us. All right, so here we see the label of 1. For the label of 1, we are supposed to receive B. Well, let's see what happens when I feed it through my neural network. All right, so there you go. There's all my student data. I'm gonna send it. Okay, it was fed through the neural network. And according to my neural network, the student would get a C. Well, it's only 83% accurate. It's meant to make mistakes. All right. We can make predictions now. We can pass in different data, and it's all being able to scale correctly. We can cast it into an actual PyTorch tensor. But when we make these predictions, well, in the drawing that we talked about, or the explanation that we talked about here, so far what we've completed is the student portal, or the student side, right? Where a student is able to send data and a prediction is created from that. Well, what about the teacher side? Right? How does the teacher see all of these predictions? Well, the way that works is we would have to store this in some sort of database to then run a GET request to grab this information. Well, how do I store this inside the database? I already have the database, right? And I have the information that I need to be able to store this. All I would do is add a couple of lines of code, which is going to be write record onto DB. This is going to say db.session. I'm going to add my predictions. Oh, excuse me. First, I want to create an instance of the class, right? Which we have as a prediction model. So I can say new prediction is equal to the prediction itself. This is going to take in input data. And the input data that I want is going to be a stringified list of data.values. I'm essentially grabbing all of the values out of my data and creating a list. From there, I'm going to stringify it so that it can actually fit into a text field, because that's what I have input data as. I'm doing that for simplicity's sake. Then I'm going to take my prediction, which my prediction, if I am correct, it is an integer type. All right. So my prediction would just be int predicted. There you go. So there is my prediction. And seems like that didn't necessarily work here. Let's see, in predicted. Let's go again. Oh, there you go. Put an extra parentheses there by accident. All right. So finally, I have my new prediction. I can add into the DB, and then I can commit it into the DB. Well, now, let me run my server one more time to make sure this is working. All right, my server is working. I'm gonna send my request. And in PSQL, when I run select all, I have the ID, I have the input data, which is the entire string of all the different data that was fed into my neural network, and then the prediction that was created. So I could do this a couple of times here. Let's say these were different students. All right, let me grab a couple of them. This one's a 4.0. Or yeah, it should return a 4, which I believe is a D. Or excuse me, that should be an F. I could send this. Now we can see that it's an F. So it's able to make those predictions. I can run select all. And there you go. You can see we have a couple of 2s because I send the same one over and over again. And then I see F for my predicted value of that last student. Great. Well, now in the teacher side, I can have a view or a function that will return all predictions. So I can say def return predictions. Excuse me. This return predictions, and I know I've been going on for a bit. I apologize, but we do have retro right around the corner, so I'm trying to finish out so we can take a good break before retro. This return predictions would then route predictions is equal to prediction dot query dot all. For there, I'm gonna say labels is equal to x dot prediction for predictions for x in predictions. And then finally, I'll return a JSONify of labels. App.route. And here I'm going to do predict again, but I'm just going to change the methods to be equal to get. All right, let's make sure this runs. All right, gonna go over to predict, run a get method. I'm gonna run a send, and you'll see that now when I run a get request, I get back all of the different predictions for each student. And we would utilize that to then build the teacher portal, which shows the applicant registering for the class and the expected grade that they would want. All right, so there's a little bit more formatting that we need to do to send this response to be able to generate that. But essentially our React code would just map through that list of objects and create a component showing the student information and their expected grade. All right, Momo.
So we will not turn this numbers to letters again.
We could. Definitely could. We could just let me go here. I can say
Let's reverse.
grades get. And then I could send the request again. Oh, X, did you get? Did I misspell something? I probably did. Let's see, grades dot get X dot prediction. No, I did it right. What are you complaining about? Let's see, attribute date object has no attribute get. There you go. All right, so there you can see all the letters of C, 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 and F, right? And then you could even go a step further and grab the student ID. We don't have the predictions set up correctly to be able to grab the student ID. Because that's within my input data, right? So within input data, here's the student ID. So there's a little bit of more formatting that needs to be done to be able to create this correctly. Does that answer your question, Mama?
Yes, sir. Thank you.
Of course. All right. Okay. If no one has any questions, I want to make it clear, this is more of a stretch than anything, right? This is not expected for people to be able to formulate this at this point. We haven't talked about CRUD, and we haven't talked about, you know, a lot of the concepts that we're utilizing here, like object relational mapping, which we'll see in the Django module here. This is more of a quick introduction into everything. So if this feels like it's extremely overwhelming, that's okay. What we need to get out of this class specifically is we grabbed our model, we were able to train it, store all of my model's parameters in this model underscore path. We also grabbed Scalar's parameters in the scalar.pickle to be able to scale our data as we receive it within a request. We then were able to send a request, receive students' features, format them into a data frame that we could then scale utilizing Scalar, and then turn into a tensor utilizing torch.tensor. Finally, we fed this torch of features into our model to provide an output, which we then made into created a prediction from. And then this prediction simply was turned into a B, C, D, or F, depending on the matching that we had from the student cat, right? So here we have 0 matched A, 1 matched B, and so on. And that's how we were able to send a post method to predict where our student features were placed within the body of our request. The prediction is made, and we receive back what the prediction is from our model as to our students' performance within the class. All right. At this point, does anyone have any questions over anything I've covered today? Okay, fantastic. The next thing that we have on schedule, and let me actually stop the recording here.